Alright, so we're about to work on my favorite part of this chapter, in this section, 4.3, is the properties of logarithms, because this is where we, I don't know why I like it actually, it's just, it's fun. I think it's fun. I hope that you will take the approach of trying to have fun with it, because it's just like working out a puzzle, you know, it's all about strategy and it's fun. So we've got a toolbox of properties that apply for logarithms, and one of them, the first one, is the product property. And it is that if you have a log of some kind of base, and the argument is a product, you can rewrite that as the sum of two separate logarithms, one for each factor. So let's test it out and see if it works, shall we? How about if we had log base 2 and the argument was 32? And we wanted to see, we're going to see if we rewrite this. Let's just test out this theory that you can write it as a sum of two logs. Let's see, the products here could be 4 times 8, right? And then we would have the log base 2 of 4 plus the log base 2 of 8. All right, so we're going to test it out and see if it works. So first we'll just evaluate the log base 2 of 32. And remember, a logarithm is the exponent you would need to raise the base to in order to get the argument. So if I rewrite this in exponential form, it would be 2 to some power is equal to 32. So if you raise 2 to the power of 5, you'll get 32. Therefore, this whole expression here is equal to 5. So I'm going to write 5 equals, and then we're going to evaluate these two pieces and rewrite them here and see if it adds up to 5. Alright, so this one first. 2 to some power equals 4. Well, we know what that is. That's 2. And 2 to some power equals 8. Well, that would be 3. And what do you know? 2 plus 3 does equal 5. Awesome. So let's then go on to another example. Alright, so actually we'll not do another example. We'll just say, okay, we found one example that works. I think I believe the property. I think I believe the property. So the product property works. What other properties do we have? We have the quotient property. Oh, that sounds good. Let's take a look at that. The quotient property is, well, what is a quotient? Well, just like the product is a result of a multiplication of two factors, a quotient is the result of dividing. So our quotient property is that the log of some base with an argument that is the quotient of two numbers can be rewritten as two separate logs. This time we're subtracting them though, so that would be x and y. Okay, should we try? Or do you just want to believe me? You just want to believe me, right? Okay, and then what else? We have the power property. The power property is when you have the log of some base, and then the argument actually has an exponent on it. Well, when that happens, you can rewrite this with the exponent being multiplied in front of the logarithm, like that. And that can be really useful. And also a couple of other properties that are very important to keep in mind is that the log of some base with the argument of 1 will always equal 0. And that makes sense to us, right? Because a to the power of 0 is always 1. If you rewrite that in exponential form, no matter what the base is, if you raise it to the power of 0, you do get 1. So that makes sense. And what else? The log... Whoopsie. Something's happening. The log base a of a. Okay, so when your base and your argument are the same value, what happens? What do you think it's going to be equal to? You want to try to guess? Well, if you rewrite this in exponential form, that'll be a to the power of something equals a. Yep, you're right. It's 1. A to the power, or log base a of itself is 1. So those are our properties that we're going to be using in order to answer some questions. But we're going to start off with just rewriting logarithms using those properties. And, well, actually, I want to do one like this with letters in it. So the log base a of the quotient, which has a product in the top and a product with powers in the bottom. This one is like the most complex example you could possibly get, which is why I chose it, because it's so much fun. So first of all, I'm going to apply the quotient rule. So I'm going to look at this as the top and this is the bottom. So I'm going to rewrite this as the difference of 2 logs of base a, with the numerator first and the denominator second. And then we can expand this even more. We can do, that is the log base a of m plus the log base a of n plus the log base a of q. Okay, so that was all that first expression, and then minus, now here you want to be careful because we're subtracting and it's going to be a sum because we've got a product in here. So I got to make sure to be careful with that negative because it does need to be distributed after I have expanded this part of it. Okay, so then I have the log base a of p squared plus the log base a of t to the 4th power. And I can distribute that negative. I'm just rewriting everything. And then the log, oh, okay. I'm going to distribute the negative. Yeah, I'm going to do that. But I'm also going to move this exponent in front of this log so that it's 2 log a with the 2 times the log base a of p, and then the negative also gets distributed to this part. So I have negative, and then I also want to move this in front for log base a of t. Alright, so if you could handle that, you're alright. You can handle anything. But let's look at a few more examples that are maybe not quite so involved. How about, let me see, what do we have here that we can do? It's going to be so fun, guys. I'm going to choose a really fun one. Number 63 from the back of the book, log base 2 of 6x over y, so that's my argument right there, is log base 2 of 6x minus log base 2 of y. And this one can be rewritten as log base 2 of 6 plus log base 2 of x, and then bring down the minus log base 2 of y. And we can probably simplify that a little further with this part, but I don't want to because it's not a clean number. It's going to be some kind of approximation. So we'll leave it in exact form. So that'll be our final answer. Yay! Let's go on and do another one. That was fun, right? Let's do 65. The log base 5 of 5 times the square root of 7 over 3. Okay, so that's the log argument. So that'll be the log base 5 of 5 square roots of 7 minus the log base 5 of 3. And then this can be expanded. So I'm going to make it the log base 5 of 5 plus the log base 5 of root 7 minus the log base 5 of 3. And this can actually be rewritten as 7 to the 1/2 power. And then this can be simplified to 1. The 1/2 can come in front of that. And I think that is expanded and simplified as far as it can be. So we'll move on and do another one. Wasn't that fun? So fun. Number 67. Log base 4 of 2x plus 5y. Okay. You might be tempted to try to do this. Something like that. I've seen a lot of people do that. It doesn't work that way. It does not work that way. They have to be 2 separate logs, and this is not 2 separate logs. And you can't distribute a log. This part of it, you cannot like go and make this the log base 4 of 2x plus the log base 4 of 5y. You cannot do that. It doesn't work like that.